All right, boys and girls, this is the Unit 1 practice test for calculus. So this is a very close version of what the actual test is going to be. All right, so here we go. We want these lines to be perpendicular. So what I'm going to do is I'm going to start with this equation, find the slope, and then I will determine what the perpendicular slope to that would be. So we begin with x minus 2y plus 7 is equal to 0. So I add 2y. That leaves x plus 7, and then I divide by 2, which would yield a 1/2 x plus 7 over 2. So right now, the slope is 1/2, thus the perpendicular slope is equal to -2, the opposite reciprocal. All right, now, this is what I'm trying to solve for, the k in that. So 6x plus ky minus 5 is equal to 0. So if this line is perpendicular, that means its slope will be -2. So let's see what the slope right now is. So I'm keeping the ky, I'm subtracting the 6x and adding the 5, and then I divide by k. Okay, so for right now, I see that the slope is -6 over k. So if this line is going to be truly perpendicular, that means that slope, -6 over k, has to be -2. Switcho changeo, k is equal to +3. All right, find the domain. So any illegal x's. So the first thing that I look at is that numerator. I can't have a square root of a negative. So that implies that the x plus 3 has to be greater than or equal to 0. So if that's the case, x has to be greater than or equal to -3. Another thing that I can't have is I cannot have bottom zeros. So that means x squared minus 2x cannot be equal to 0. So I factor out a x, and that implies that x cannot be equal to 0 nor +2. All right, so kind of thinking of this on a number line, I have the number -3, have the number 0, and I have the number +2. And so x is greater than or equal to -3, but cannot be 0, nor can it be +2. So this is kind of what I have to describe. And so it would be this guy right here. Okay. Which one is symmetric about the y-axis? That would be the even. So these have exponents of 4 and 0. This ultimately would be an x squared plus 4x plus 4 with a 3 on the outside. However, long story short, that's a 2, 1, and a 0. Here, this is a 3 and a 0, and this is I think a graph that looks something like that-ish. So symmetric about the y-axis, that implies that this thing is even. So I see that this guy right here is even. Which function is not odd? Okay, so the cosine is a graph that starts at the top. This one is not odd, I know that right from the get-go. Going through the others, x to the third, looks like that, so that's odd. Sine starts in the middle. That's odd. And then an x, third root of x. Just like that, that's odd. So the only one that is not odd is that first. Find the solution to this. Okay, so when I have an absolute value, what I want to look at is the positive and negative version of the answer. So what I'm looking at is where is x minus 3 equal to 2? And where is x minus 3 equal to -2? All right, so we get 5, and positive 1. Thinking of those on a somewhat of a number line. So I have the number 1, have the number 5. What I'm going to do is I'm going to test the numbers. So for instance, what I mean by that is I'm going to test something bigger than 5, like the number 10. And whatever happens to 10 happens to anything bigger than 5. I'll test a number between 1 and 5, such as the number 3. And whatever 3 is showing will exist from 1 to 5. And then I will test a number smaller than 1, like the number 0, and it will tell me what's going on below the 1. So for instance, if I test the number 0 up in my equation, I get 3 is less than or equal to 2. That's not true. If I test the number 3, that would be 0 is less than or equal to 2. That is true. I test the number 10. That would yield 7 is less than or equal to 2. That is not true. So right here is the good stuff, from 1 to 5. And so that would be 1 to 5. Find the roots. This is complex ABC. So 2x squared plus 3x minus 2 is equal to 0. So complex ABC is you multiply the first and the last. So 2 and negative 2 is negative 4. And I find all the different ways that I can multiply to negative 4. Okay, I add to that middle number, which is a positive 3. That's the one that adds to a positive 3. And then I write the very first term as a fraction twice. So 2x, 2x. With the selected pairing as my denominator. And then I simplify if possible. These are going to be the factors. Okay, those are the factors. So I'll write that in my official work here. So if that's equal to 0, that implies that x is equal to positive 1/2 or negative 2. So positive 1/2 or negative 2. There you go. Okay. All right, trig time. So let's start with our unit circle. Let's just see what we got here. So cosine of 5 pi over 6. So 5 pi over 6 is a small angle right there. That exists at negative square root 3 over 2 1/2. And thus the cosine is the x coordinate of that. So that would be negative square root 3 over 2. Because all points come in the form of cosine, sine. All right, next we have negative pi over 3. Pi over 3 is a big angle, but this is a negative, so a negative big angle right here. So this would be positive 1/2, negative square root 3 over 2. Again, the cosine is the x coordinate of that, so that would be positive 1/2. Next we have pi. Pi is right here, which exists at negative 1, 0. Tangent is the same thing as saying sine over cosine. So sine is the y-coordinate, cosine is the x-coordinate, and so that would ultimately be equal to 0. Next we have 3 pi over 4. 3 pi over 4 is right here, which exists at negative square root 2 over 2, square root 2 over 2. Another way to look at that, you could think of it as negative 1 over square root 2, 1 over square root 2, if the problem dictates that that would be easier, which I think it would be, because secant is 1 over cosine. So 1 over the x-coordinate would be negative 1 over square root 2, which would just be a simple reciprocal of that. So that would be square root 2 over negative 1, or aka negative square root 2. Last but not least is this negative 11 pi over 3. Now, anything over literally the number 2 is not necessary. So what I'm going to do is I'm going to, in essence, subtract 2, or aka 6/3, off of this. And so what this would leave me with 5 pi over 3. So that's what I'm really going to look at instead of the 11 pi over 3. Let me do this in orange here. So we got negative 1, negative 2, negative 3, negative 4, negative 5. Negative 5 pi over 3 right there. which is going to exist at 1/2 square root 3 over 2. So small x, big Y. Cosecant is 1 over the, 1 over the sine. So this is 1 over square root 3 over 2. So it would be the reciprocal of that, which would be 2 over square root 3. Moving the square root up, that's 2 root 3 over 3. All right, next we have graphing. So the first graph is a, sorry, give me 1 second, sorry.
We'll be having our meeting shortly in row 228.
Sorry.
Again, all GUEA site leaders. We will have our meeting shortly in row 228. Thank you.
All right. So we just need to know the manipulation. So x is live but not the y. So that's going to be left 3 down 2. So the x is live but not the y. So left 3 down 2 puts me right there. And then this is just a straight up square root from there. Please be very specific on how you graph this. Don't roughly graph it exactly how it's supposed to be. Please keep that in mind. Okay. Right here we have a goofy graph. very, very specifically. Here's how I do this problem. So I solve for y. So 3y is equal to negative x squared minus 6x. Okay, solve for, and okay, I'm going to keep it right here just for a second. I'm going to GCF what I can. So I'm going to take out an x, and so this is x plus 6. All right. And now I'll get rid of the 3, so I divide by 3. So this is ultimately negative 1/3 x plus 6. All right. Now what I get out of this is a few different things. One, I see that it's a negative x squared, so that lets me know that this is a frowny face. Next, I know that I have roots at 0 and negative 6. All right, so knowing that, let's just use that to our advantage. So 0 and negative 6. All right, so that would imply that the vertex of this is going to be at x is equal to negative 3. So what I'm going to do is I'm just going to plug and chug negative 3 into this and see what the y coordinate would be. So if I plug in negative 3, that would turn into a positive 1. And then negative 3 into that would be positive 3. So I see that I would have a vertex at negative 3, positive 3, with my roots at 0 and negative 6. And then that's good enough to get my picture. All right, here we have a y squared equal to 1 minus x. So this is going to be y plus minus square root 1 minus x. So I know that important stuff. What makes this equal to 0 is x is equal to 1. So it's going to stem from there. Now notice that I cannot put in positive numbers. Like I can't put in like negative, or x can't be 3, for instance, because that would create a square root of a negative. All right, so what that is letting me know is that my square root is opening that way. Okay, it's opening backwards. So, but it's just a basic square root, so it's a 1, 3, 5. So go up 1, 3, and then 5, 1, 3, 5, goes out like that. Two cosine. All right, so this one, I don't know if you know how to graph stuff. This says this has an amplitude of 2, and this is up 3. From that, it's just a general cosine. So let's go up 3. amplitude of 2. That means it has a height of 2. So the top floor is up 2, bottom floor is down 2. I'm going to make my own kind of scale here. And I'm going to say that this is pi. And 6 is 2 pi. All right. So I'm just kind of making my own scale here. Down and up. And this is how you graph the cosine. All right. Last but not least, this is a circle. What you kind of need to know is how to quote unquote complete the square. So if you need to like pause the video and figure out how to complete a square, go ahead and do that. But this is completing a square. So what that is I'm going to put the x's together. So x squared and 2x. So I didn't do anything, I just wrote them next to each other. Okay, what else I'm going to write next to each other is the y's. So y squared and 4y equal to the constant. All right, so completing the square is you take these middle pieces and you take half squared. So for instance, half of 2 is positive 1, so I take half squared. Okay, half of 4 is 2, so this is going to be y plus 2 squared. So that's the punchline. But now, for this and this to actually exist, it doesn't come directly from that alone. We need a number, a constant to go along with them. And so what that invisible added number is that half that we created squared. So for instance, we created this 1. 1 squared is 1. So in the previous line, the line that we came from, I have to add this invisible 1. For the y's, it's a plus 2. So 2 squared is this invisible 4. Altogether on the left-hand side, I added an altogether 5, which didn't originally exist. So what I need to do is I need to put that on to the answer. Now everything is legal. Now this is a circle, which is in essence x squared, y squared, r squared. Okay, and then the center is the opposite of these x's and y's. So this means I have a center at -1, -2 with a radius of 3. Okay, here we have a piecewise graph. So I'll start with this very top equation. And so that is just a horizontal line at -3, but only exists from 0 backwards. So 0 backwards, there you go. The middle equation is a disco dancer. So disco left 1. So disco left 1. So that, excuse me, disco right 1, excuse me. So that is there. So I'll just put little dots right here. And then so it'll be 1, 8. So that's 2, 3, 4, 5, 6, 7, 8. Down 1, and then 8, but that is, okay. And this is going to exist from 0 to 3. So this is going to be a concrete dot. This is going to be an open dot. All right. Last, we have a line. That's supposed to be in blue. A line. So this is going to pick up from 3. So if I put in a 3, I'm going to get a value of 6. And notice how it does not actually include that 3. So 1, 2, 3, 4, 5, 6, open dot. And this has a slope of -2. All right, this first equation, manipulations are opposite, x's lie but not the y, so this is going to be left 2, down 3. So left 2, down 3. So all of these important things go left 2, down 3. So all the important things go left 2, down 3. And that's your picture. Middle one. All y coordinates are multiplied by -2. So whatever the y coordinate is, multiply by -2. So the very first one is at -1, so that would be a +2. That vertex, the v part of it, is at +2, so that's going to be at a -4. The other one is at -2, the last point, so that's going to be at a +4. So I multiply all these y coordinates by -2. Last but not least is the absolute value. So what that means is if it's above the line, if it's above the x-axis, it's good to go. Right? So right now, that part is above the line. If anything is below the line, it's now you got to move it above the line. There you go. So anything that was negative in the y is now positive in the y. So anything that was above the line, you just double up on, and then you move anything below the line above the line. That's it.